For which of the following molecules are resonance structures necessary to describe the bonding satisfactorily? So, what is a resonance structure? Basically, you can have resonance structure for some of these molecules if there's multiple ways of drawing the Lewis structures. So let's start off with H2S. So Lewis structures are based on the valence electrons, and a really simple trick in order to figure out the valence electrons is by looking at the group. So group 1 will have 1 valence electron, group 2 will have 2, we're going to skip these, we're going to skip the transitionary metals, then it's going to have 3 valence electrons, 4, 5, 6, 7, this is my noble gases, so it'll be 0. So I have 2 H atoms. So we know one H has 1 valence electron, so 2 of them should have 2. And you have 1 sulfur, so that's 6. So you should have a total of 8 valence electrons. So if I were to just draw that, so number 1 is H2S, my sulfur atom is going to be surrounded by H's, so this is a double bond. So I'm going to have 4 valence electrons left. And we know that hydrogen is an exception to the octet rule. So the only way that this can work is if I put 2 lone pairs for S. And that is the only way you can draw it. So H2S does not have a resonance structure. Now I have SO2. So I know that 2 oxygens have 6. Well, 1 oxygen has 6, so 2 of them should have 12. And 1 sulfur should have 6, so it's 18 valence electrons. So my sulfur is going to be surrounded by oxygens. So now I have 4. Okay. So now I could add another pair here. Now it's 2. So I have 12 left. Then I have 4 here. So now that's going to be 8. I'm going to add 6 here. So I have 2. And then sulfur will take the other 2. But you might have something different than me. And there's actually another way of doing it. Sulfur is actually in the 3rd period. And there's something that if you have elements in the 3rd period and below, so it'll be anything below the orange line that I just drew, there's something called the expanded octet rule, where these elements can actually have more than 8 valence electrons. So knowing that, we can actually draw this another way. The way we can draw this is, again, let me just draw this. I can add another pair between the S and O, right? So I'm going to have 18 minus 2, 4, 6, 8. So that's 10. So oxygen is going to keep its normal octet rule, right? It's going to have 4 more valence electrons, so 2 more lone pairs. So it's going to have 8. So I have 2 left over, but since we know that sulfur has expanded octet rule, we can actually just give it 1 lone pair. So that's a resonance structure, and once you start learning more, you'll know that this is a dominant resonance structure, but that's not really the question. So the correct answer would just be